All right, chemistry, welcome to experiment 14.1. I feel like I need to start calling this like my red wall lab. Welcome to my red wall lab, also known as my dining room. So for this experiment, the question is, see how well you can actually see that? Which factor has the greatest effect on the rate of reaction? So we are dealing with a few different factors here. The first one is going to be our control. It's going to have a set amount of toilet bowl cleaner reacting with 1/4 of a Tums. The second one, we powdered up the Tums and it's been crushed. There you go. It's crushed into little teeny granules. The third factor is going to be temperature, and we're going to have the third test tube sitting in a beaker of hot water, just less than boiling. And then the fourth factor is this toilet bowl cleaner is going to be diluted. It will be, instead of a half, it will be an 1/8. So it will be 1/4 the amount. So out of those changes, we have dilution, temperature, and this would be considered like a surface area change, the grinding it up, number 2. I'd like you to make a hypothesis of which of these 4 beakers are going to have the greatest, fastest reaction. And so here they are again. 1 is our control, 2 has them ground up, 3 has the temperature underneath, and the 4 is going to be diluted with water. So go ahead and pause the video and make your hypothesis. Okay, hopefully you made your hypothesis. It's not hard. If one of these will have the greatest effect, then the diluted one will have the greatest effect because whatever, come up with your reason. Okay, so these are labeled 1, 2, 3, there's 4, it's a little harder to see. And then 3 is in its own container because it is heated, and these are going to be room temp, which my house is about 68. This one's gonna be 200. If you're looking at Fahrenheit, Celsius, this one's probably gonna be 90, and these are gonna be at 20, 21. Okay, so here we go. I'm gonna try to drop them in at about the same speed, but not perfect. There's only one of me. Generally, you guys would all do this for yourselves. So let's see, here we go. Get them all on the screen. Here's number 1. Here we go. 1, 4, 3. Coming for number 2 with my ground up amount. Okay, so the way you're going to judge this reaction is by the foam. Here's our foam. Here's 3, which is in the hot temperature there. Here's 4. This is the diluted one. It's doing little to nothing. Hopefully you all assumed that would happen. You can see number 3 is really taken off. The temperature is doing a large amount there. Number 2 looked like it did a big, I think some got stuck. I might have to help that along. Ugh, wish I was wearing gloves. Okay, now it's making a mess. All right, there's 2. Way the heck up there. It looks like we just had a little problem. It started reacting and then it got stuck on its own foam because it was such a small particulate that it got stuck. So it is now far exceeded 3, so everyone knows. Here again is our control. 4, no surprise there, it's just plugging along. Okay, so you need to write this data down in what order they had the fastest reaction time. 1 is still going. If you can see, this is the reaction, the little bubbles at the bottom. Tums is an antacid. We have a very strong acid with toilet bowl cleaner. It's comparable to your stomach. So when you take Tums, it should make you burp because it's turning your acid, and as it neutralizes it, it's giving you some gas. It is also, that one's nice and warm. See with the other ones, how warm they are. It doesn't seem to be exothermic. This one's warm because it's sitting in the hot water. So get your data, write it down. I would like a conclusion. Tell me if your hypothesis was correct. Explain a summary of the data, and then explain why this is the case. Why was that one reacting the fastest and the most? And then give me any opportunity or chance of error that may have happened. Okay.